AI has evolved from static pattern recognition systems, okay, to creative systems, along with the context awareness. And now agentic systems have come into act or picture, and they are very much autonomous, right? So if before we move on to this generative AI and LLMs, let me start with how this machine learning, deep learning, and NLP came into picture. Like I believe most of you are aware about machine learning, if not the LLMs. So machine learning was something like basically provide or analyze the historical data to predict the future outcomes or predict what is going to happen the next outcomes based on the data that we have fed the model basically, right? Now that was all the static pattern recognition systems if I put it again. Now we have come through a journey and the technology has evolved so much that we have understood how or the revolutionary about language understanding here when I talk about it. So the generative AI started, then the LLMs came into picture, and then we are now again using RAG-based systems, then vector databases, and the agents that are the most autonomous systems in today's technological era. We can talk now. Before moving on in depth to the topics that we have, I'll just share that what the agenda of today. We have the agenda covering the complete evolution pipeline. So the evolution of generative AI, understanding how AI moved from prediction to creation. That's what just I mentioned about the machine learning, deep learning, and then how Gen AI has come into picture. Then we'll understand the transformer architecture, the innovation that made modern LLMs possible. Then understanding LLMs, basically what makes them powerful and capable of reasoning. Then we'll understand about the RAG and the vector databases, how we can extend or use the external knowledge or feed the external knowledge to LLMs to make it more autonomous. And then the vector databases, basically that how the data that we have stored, basically in this case, how we are storing the data that we provide as an input and how the outputs are also stored. Then the AI agents, how it has come. So basically, AI agents and are the goal-driven systems, if I mention here. Then we have the multi-agent systems, how these agents collaborate to perform complex tasks, and then the connecting it to the whatever we have discussed, how we can use the future trends and how we see how it is applied across different industries. So when I say different industries, it could be healthcare, it could be retail, it could be manufacturing, it could be life sciences or drugs research in all these industries where your Gen AI or LLMs or agents become your horizontal, and these industries are basically the vertical aspects of it. Moving on, evolution of generative AI. So AI, as I mentioned, it began as a rule-based systems, right? Like in a basic software programming thing, right? When we write a piece of code, we basically write a rule-based. Let's say if when I'm doing an SQL programming, I'm trying to understand a data, historical data from our transactional databases that we have, we write a small thing like if a customer belongs to so and so age group, so and so location, and so department, then give me its salary details, right? Then we give then we get a list of details of all those customers, right? So this was the basic analysis that we do earlier. Now, let's say we want to predict, let's say we have different marketplaces now, like Amazon, Flipkart, or there's so many in the market now. Now, how do they analyze their business? How do they predict their business? Correct. So what they do is that every these marketplaces or these softwares or these applications, right, or these companies or organizations, they have huge data warehouses where they store all their data. Correct. The transactional data, basically. Let's say I'm a customer, you are a customer, all of you are a customer, right? And every customer will have a unique ID. So you either your unique ID would be your name, right? Or your phone number. But in most of the cases, it would be a phone number because names could be a duplicate in that case, right? So now we have a customer unique ID. Now for each customer unique ID, you basically get all the transactional details, right? What product you have purchased, what is the bucket size. When I say the bucket size and the bucket amount, that there are two different aspects again, or two different things here again. So when you say bucket size, the number of quantities, and bucket amount is basically again the total value of the purchase you have made. Right? All these details are saved. Now, every business when they were doing right, every organization works for the business improvement, also the business how to improve their business and or improve the revenue and the bottom line or the margin. Right? How do you do that? So they have to predict in the next phase, right? Next month, what's going to be that. Accordingly, they can have the supply chain management, all this stuff. So that is where these rule-based systems came into picture. Okay. So if you can see that it came from rule-based, then it basic analysis like okay, from which understanding the demographic of each customer or the customer base they have. Then they used to see that what was the revenue for this month, what is the weekly revenue, the daily transaction, all that. Now they moved on a little bit to statistical analysis. That's where the machine learning algorithms came into place, and then the deep learning concept, because the deep learning concepts came into place where these recommendation systems came into picture. I believe everybody would be or would have experienced this concept of recommendation, right? I'll give a simple example. If you go to YouTube and search for some kind of content there, right? If you search it today, right? Next day onwards or after some time, you'll receive similar kind of content in your ID, right? To subscribe or this. How does it work? It works basically on an engine called the recommendation engine. They try to capture all your data, whatever we Google or whatever we search. Right? Every systems are interlinked in the backend. They try to capture all your details. Basis on that, they try to recommend you the products or the content to you. Okay, I have experienced this. Let's say if you go to YouTube and search for content, okay, some funny videos, right? Some funny videos. Let's say you want to see Charlie Chaplin's videos, or you want to see Kapil Sharma's videos, right? So you have watched it today, right? Couple of his videos and all. Tomorrow, right? When you come, right? You'll see a list of Kapil Sharma's videos or Charlie Chaplin's videos coming to you or recommended to you on your screen. Have anybody experienced this? Also, you try to watch some of the motivational videos. Okay, there are a lot of motivators available on the on YouTube, right? So you'll get a lot of motivational videos coming to you. Only the motivational videos. Yeah. So the how does this happen? How do they send or post those content to you? It's on the recommendation, basically on the recommendation engine. Okay. So it is like content based recommendation, then you have product based recommendation. Everything happens in the backend, and all these concepts work on the deep learning concepts here. Okay, because you have huge amount of data, and this data needs a robust or scalable system that needs to be trained on, right? So that's where deep learning systems and the neural systems came into place, and at some places, image recognition also came into pictures. Okay, so that's how deep learning started with. Now, from deep learning, then we have moved on to generative AI, right? So whatever was happening was that we used to feed the data to it, then we used to get the predictions. But in generative AI, what happens is that you basically provide an input. It's like a human-like language interface, right? You say that I want to know the sales of so and so product today in Google, you can say. Okay. Or what was Amazon's revenue, or what was Amazon's revenue for the big billion days it went for, let's say, or Flipkart. What was their revenue, right? You'll get an overall idea of it. How does it happen? In the backend, it understands your queries. It interlinks or it links to different internal sources of there. Okay. Whether it could be their own databases. Ideally, you will not get all the databases, only to some extent when they declare the revenue on the website, right? They make it public. It will try to fetch. That is basically the web data, we call it. And it relates to the other components of it as well. Then that's how it generates the output. Okay, for during the big billion days, Flipkart had a revenue of $1 billion or something like that. That's where the third wave came with deep learning. Again, in generative AI also we use deep learning, where we use a lot of neural networks, but we have moved a little bit ahead, right? That's where we got these GANs, the generative adversarial networks, then the VAs, the encoders. Okay, then we had the diffusion models. Then that again introduced this creativity on this. Okay, now how these models came into picture, right? What was the architecture of it that transformed this complete natural language processing that we provide? Okay, then the language that we give and the content that we generate from generative AI, like it could be basically the generative AI mode of most. I believe most of you have used ChatGPT at least once in your uh, once all these years, right? No, please don't deny this that you haven't used ChatGPT. Everyone has used ChatGPT, right? So what happens is that in ChatGPT you basically give a small input to it and it generates content, right? So how the engine in the backend understands this content that you provide or the input you have provided. It's completely based on an architecture or the paper that was basically written by Google Brain. They came up with attention is all you need. That transformed the entire natural language processing. So earlier it was basically the sequential learning or the sequential processing of the text that we had. Now what it does is that if you provide 100 lines of sentences or 100 sentences in a paragraph, right, or big paragraph, 100 sentences, it does in parallel at a time. That is what generative AI and the beauty of LLMs we have. Next, we'll see how the foundation models rose and what are the different open space or open source ecosystems that we have. And then we'll see how Gen AI enables creation, but not the prediction only.
I have a question.
Yeah, please.
In order to serve this data, let's say from the generative AI, from ChatGPT, or in any such order where the LLM is bringing those data, so is it suggested to have a open source database or any
It's
Microsoft? Yeah.
we do not have an open source data uh, basis here. See, when you say open source database, databases are not open source. I can say you have the applications open source, right?
Mm.
So in GenAI, basically, like when we talk about these agentic systems and all, earlier, I'll tell you how it has evolved. Okay, when we go to the vector encodings and vector databases, right? So
No, my
the
question
architect
is like Cassandra and NoSQL based databases is recommended, or any uh, relational databases are suggested to.
here basically we have the it's a good question actually. No SQL based databases we have here.
Okay, okay. Yeah,
Yeah.
thanks.
Yeah. So now to understand the transformer architecture here, the engine behind LLMs. So the transformer architecture is the backbone of modern AI models, and this was introduced in 2017, right? So it replaced the sequential models like RNNs. The RNNs are nothing but the recursive neural networks and LSTMs, the long short-term memories. So initially, when the deep learning evolved, right? So people basically worked on this ANNs, artificial neural networks, then CNN, okay, convolutional neural networks, where it basically was more into image recognition, right? You provide a picture of the cat, right initially, and you train that model, and it uses the different neural networks. So these neural networks will have a hidden state, and these hidden states will basically have different input layers in it, right? And these based each layer will basically have a vector or vector space, right? And each input will be assigned a weight to it. Based on this weight, your output would be predicted, right? And it was not an iterative process, right? That's where your RNN came into place. Now, RNN also it was again a sequence to sequence kind of a algorithm, right? Where let's say I want to I'll give an example here. The cat sat on the mat, right? So how many words do we have? The cat sat on the mat. We have 5 words here, right? So RNN what it will do is that it basically takes this 5 word, the entire sentence, and breaks into 5 words or 5 tokens. So now these 5 tokens are called as an input to the model or the neural network here, right? So what will happen is that let's say we have, I'll rename this as x1, x2, x3, x4, and x5. Now when we feed this into, right? So this will be encoded first, okay? And once these are encoded, it again assigns a weight to it, tries to understand the context of each word, right? And based on that, it will try to predict the or process the entire sentence. Now, what happened is that it didn't had a memory in it to store what happened. So now if I feed another word to it, right? The cat sat on the mat as it was tired, right? So now when I feed that again, so what happened is that the previous session or the previous input that is provided to it, it was not preserved, right? We didn't have a memory. Then came the concept of LSTM, the long short-term memory, which was very much useful in when you're trying to forecast or when you try to store your input, relevant input for some time. That is very much useful. And many forecasting techniques like you say this. Uh, how can I put it, like machine equipment, the how to find whether whether there is a defect in a machine or not. Okay, to understand the lifetime or lifetime value of an manufacturing equipment, right? Where you get lot of sensor based data, right? Every minute, every milliseconds you get, or 30 seconds or 5 minutes, right? That's where you have to preserve, or the model has to preserve the last scene pattern of it, right? So that's where the LSTM part of neural network came into play. Now, again, the drawback in this RNN and LSTM was that it was not trained parallelly. It was happening one by one. That's why it was called a sequence to sequence. Right? Then the key innovation came into place, that was for the self-attention for contextual relevance, that is in the transformer architecture, where everything happens in parallel. So the transformer architecture basically came up with the encoder decoder setup, okay, that completely enables your language understanding what we provide. Now we say that the cat sat on the mat. It takes the entire sentence and processes every token in parallel. Am I clear? So if in this architecture, right, we basically have two main components, the encoder and the decoder. So the encoder basically reads or understands the input text, while the decoder generates the context aware output. Now each layer contains the encoder layer and the decoder layer. Right? It contains multi-head attention, the feed forward neural networks, and the positional encoding to maintain the order. So once we put the data into the, or you write human language, right, whatever sentence you write, it feeds into the encoding layer or the encoded layer, and then you have the positional encoding. So positional encoding, what it will do is that it will try to understand the position of each of the tokens or the words that you have provided, right? And based on that, it will try to create or generate a weight for it, right? And once the weights are generated, based on this, it will try to produce an output, and that output becomes as an input to the decoding layer. Now, in between the encoded and decoding layer, we have this self-attention, or the attention score has been generated. That is called the weighted sum and all. I'm not going too depth into it, the mathematical calculations of it. Score is generated. So that score will basically tell you the relative importance between each tokens you have provided, and at the end it will try to predict the next word or sentence you are asking the system. Got it? And this architecture basically enables massive parallelization. So at a time, right, trillions of tokens of data has been, or trillions of tokens of data get trained. that allows these LLMs like GPT-4 or GPT-5. Then we have Cloud from Anthropic, and we have Gemini from GCP, right? Then we have Microsoft Copilot from Microsoft, right? Then we have Llama from Meta. So these are all the LLMs that we have. So these are all the pre-trained LLMs that we have. They have already trained on huge amount of data, trillions of tokens of data with very big infrastructure that they have, and that's how this parallelism and has enabled them to evolve across these applications. Any questions here on the transformer architecture before I go in depth of language models? Okay, fair enough. Now moving on to the how the large language models are built and to understand more about it. So LLMs are again the deep neural networks, as I mentioned earlier, built upon the transformer architecture. So they're trained on massive data sets like books, code, research papers, or the online content that it sources from different social media applications or social media sites, right? To learn the language patterns here, right? Whatever we provided, it understands at a human like language, and it generates the output as a human-like language. So it nowadays we do not only see that it generates human-like language only, the content or not. The LLMs generate images, the LLMs generate speeches for you, LLMs generate videos for you, different types of contents for you. It is multitasking, you can say. So that is where the multi-model systems come into multi-model systems come into picture, right? So in LLMs, basically the training, so every model, right, before it was developed, correct? So it is trained on huge amount of data that I mentioned, and this training happens in two phases. That is your pre-training and fine-tuning. Now, during what happens in the pre-training? During pre-training, models learn the general linguistic or the general language or the human language structure. And during the fine-tuning, it basically specializes itself that whether you are working for a task like chat, or you are working for a task like summarization, or you're like working for a chat like sentiment analysis. Because these language models, right, you may ask that, okay, I generate some content for me on GenAI, generate some content for me on yesterday's news. So it will basically give you a content. So some other person may need that I want to generate a summary of my business, okay, for the last 1 week. So these things have already evolved and has been implemented there. What your LLM, it will basically connect to your different data sources internally within your company, and accordingly it will give you the output. That is where it LLMs are doing the task of many data analysts at a time. Okay. Now earlier we had when before LLMs, right? Like 5, 7 years back, we had there was a buzzword for a lot of data analysts, then business analyst and business analytics and all. But now slowly that work has been done by the LLMs here. So you use a pre-trained LLM, and then what you do is that you provide all the APIs to it. When I say API, it is not only the web APIs. It could be your internal data sources. It could be your internal reasoning sources that you have, different systems you have, right? And from there, it will basically try to source your data, correct? And it will try to generate a summary out of it. You got it? So that is how your LLMs work when you ask for a summary like your business summary or your revenue summary, all these details. And in some cases, you also ask for sentiment analysis, like you provide different types of content to it, and you want to do a semantic match, or you want to do a text match between these paragraphs, and you want to identify some kind of errors and all. That's where your sentiment analysis comes into place. Now, these LLMs have concepts like or are trained based basically on the tokens that I mentioned. Like a sentence has is been broken into different tokens, and then the embeddings are created, the vector embeddings. Now, everyone might be wondering that when we provide a human-like sentence to the model or a GPT, right? How does it process it? It basically, or how does it stores it? It basically breaks these tokens into vector embeddings in the vector space, and it does a dot product between it for similarities and all, right? And the embeddings are stored in vector databases, which I'm going to talk in the coming slides about. And then the attention mechanisms are being applied to this LLM. Okay. So once this attention mechanism is been added, right? We generate an attention score that is relevant to each of the words or the tokens that we have. Then these embeddings represent the semantic meaning in the vector space. Okay. So when I say the vector space, it's the vector DBs that we have created. And then the attention defines the context weighting, because context weighting, basically the weights that we apply to each of the tokens that we have or the embeddings that we have generated from the input language. Okay. Now, how all this happens basically. So this entire system, right, works on the probabilistic system. It basically works on the probability. So what they do is that we try to see that we're trying to predict the next word. So how do we predict the next word, right? Anything. Let's say, what is the probability of raining in next 1 hour? So everybody will have a number in their mind, correct? Similarly, when we provide an input to the language model, they also work on this probabilistic way of understanding it, and that's where they predict the most likely next word given the prior context, because we are giving some inputs to it. Let's say I just extend that input that we discussed some time back. The cat s- sat on the mat because it was tired, right? Now, cat is an object here. We're talking about the cat here who sat on the mat, and the it is there, right? So how the it is related to cat here, the model will understand that, okay, that it is related to cat here, and accordingly, it provides a weight to it, right? Now, next time what happens, you provide any such input to the language model, it will try to save the context of this sentence in its vector database or vector space, right? And next you ask that, what is the cat going to do next? Right? Basis on that, now we'll understand that it and cat was already there, and now I'm getting an input again related to cat. So accordingly, it will try to predict the next word. This is basically a simple example that I'm giving you. Okay, so that is how it works. And behind these large language models or the LLMs, we have something called as reinforcement or the instruction tuning, right? So every time whenever we give this, the instruction tuning happens. That is called as that is called as prompt engineering, right? So we have to be very careful. Now, everybody can go back and see that whenever you're asking something in the chat GPT, the better you write the prompts to it, right? The better you ask, you'll get a better output. There are particular steps or the best practices or the best principles to write a prompt. Even within the LLMs, right? When we're using LLMs, when you're developing agents and all, there is a key rule book that how you need to provide your prompts. If your prompts are not good, then you will not get a better output, because your LLM will not get the context, or it will not generate the context that you have provided to it. Getting me? So that's where this reinforcement and instruction tuning thing comes into place. That is called as prompt engineering. Otherwise, it will not be able to reason generate the reasoning based outcomes basically. Yeah. So LLMs are nothing, again, the backbone of the most generative applications today. If I can mention like a couple of examples that I gave, like GPT, Claude, Gemini, Llama, Mistral. Yeah. And their application is into text generation, code generation, summarizing content, and giving reasoning based outputs. Any questions here? Anybody before I move on? Let's be interactive. Right? Shall I move on?
Yep, sounds good.
Yes, please.
Okay. Now moving on to the vector databases and embeddings. Like, okay, we have got the input now. We have generated the vector embeddings. We have generated the weights. We have generated the attention scores. We have allocated everything. But how do we store this data, right? We need to store somewhere the embedding. And these are basically done in a vector space, correct? So that is where your vector databases come into picture. And these are different than the relational databases that we have. Someone asked a question, right? Whether we use NoSQL and all, because your data is unstructured. So data is of two types. One is a structured and one is a unstructured. So now whatever we are providing as an input to the LLMs, these are the unstructured data that we're providing, correct? They do not have any structure. So if anybody is aware about GCP cloud storage or GCP cloud storage, then you have AWS S3 and all. So these data sources basically they contain the unstructured data. Why it is called unstructured data? Because you can store a JSON file, you can store a text file, right? You can store Packet files, so all these files, but you cannot store these Packet files, the JSON files in a BigQuery, right? Because BigQuery is a structured database or structured data warehouse, correct? That is why the vector databases or vector DB came into picture. Now, what is the embedding here? So the input that we provide are broken into, or embeddings are generated out of it, and these embeddings represent words or sentences as high dimensional vectors, capturing the semantic meaning of that particular sentence or the input. Okay. Now vector databases store these embeddings that's been generated and use the similarity matrix that I was talking some time back. So we have some concepts or techniques like cosine similarity to see the similarity between each token, that they try to generate the relative importance or the relevant information efficiently for each of the tokens or the input sentences that or the language we provide to the LLM. Now, once these embeddings are generated, uh, whenever a user queries, right? So the system basically tries to capture the embedding of the query, it from that query itself, right? And it will compare to each vector that's been stored. Basis on that similarity, right, or the vectors that's been stored, it generates the semantically similar data accordingly. So we have the some of the examples that we I can give you on vector databases that are already available in the market. FAISS, Pinecone, Chroma, then Milverse. So these are some of the databases we have that store the vector embeddings. Now, this architecture basically power, powers the search, recommendation, personalization, and the RAG pipelines. Okay, so what is RAG here? So RAG is nothing but the retrieval augmented generation, and that is somewhat to related to semantic AI search. So I'll tell you in the next slide. Now moving on, what is RAG here? Now we have understood that okay, LLM generate the human-like language or whatever input you provide. Right? It generates an image, it generates content, summaries, all that. But LLMs also have some disadvantages. What is the biggest disadvantage in LLM? It's called as hallucinations, right? Every time we see, right, whenever you search something, whenever you do a search on ChatGPT as well, it says that it may not be accurate 100%, right? So on a basic foundation or the foundation model, right, whenever we get an output, it is related to or it generates the output that was trained on the amount of data that was fed to it. Okay. So when I say let's say that I have only trained the model on 10 pages of input, right? Then it generates the output relevant to that 10 pages only, right? That was one of the biggest hallucinations. So if you ask some questions outside of it, it wasn't able to generate that output. or it wasn't able to give you the context, right? So that's where this retrieval augmented generation come into picture. So RAG basically bridges the gap between what a model already knows, that is already trained on, and what it needs to know, right? So this RAG basically has a separate knowledge base, and these knowledge bases are created when it connects to different factual APIs or external world. So your LLM will have a component where it connects to the outer world, external world, to different sources, and it gathers the input from there, and it retrains the your model, and accordingly it gives you the output, so that it considers the foundation model is very important here. On top of that, you are giving an additional layer of external knowledge here. So that is why it is called as RAGs basic. That is the concept came as augmented. Augmented is nothing but when you're adding something. You're adding knowledge to the LLMs. As simple as that. Is that clear, everybody? RAG. Okay. Now, what are the steps in involved in RAG here? So as I mentioned, the RAGs combine LLMs with an external retrieval mechanism or the data sources. So there are basically three steps here. It converts the user query into embeddings. Okay. So these embeddings are again the vector spaces or the numerical representations of the meaning of the words or the tokens. Second, it retrieves relevant documents from a vector database using similarity search. Third, inject that context back into the prompt for the LLM to generate a grounded or factual answer, right? Out of whatever data it has got into it from the foundation model or from the outer world or the external knowledge it has, it generates a context aware output. So this approach basically enables the domain specific Q&A. Let's say you are working on a project, you are doing some drug research, right? Let's not say drug research. You're doing some financial analysis of a company or your organization. So you have all the finance related data in your databases, and you have given some invoices, you have given some what do you say, financial output or the summaries, right? So before listing it in a company or when before a company is going to get public or listed in NSE or BSE, right? So you've given all the details. Now to get more data out of it, when a user comes and asks an LLM an output that is not available in this data, right? It will try to fetch other sources, or it will try to link or reach out to the other external knowledge bases that is available. Basis on that, it will try to give you the output. It's a small example. Anybody, any questions? Now we have understood about how GenAI has evolved. Then what is the engine behind GenAI, the LLM? Then how the vector embeddings are stored in a vector databases, then how we improve our LLM output using the RAG-based systems. Right? Now, what is AI agents? Right? What are AI agents now? So we are now discussing the journey from GenAI to AI agents. We have covered until RAG, LLMs and RAG. And we'll see that what is an agent. Agents are nothing but the autonomous systems that's been evolved out of the LLMs that we have. Now, whatever we did until now was a kind of static again, right? Where an LLM, though we have this attention mechanism, everything, it stores the memory, but an LLM is required more memory, okay, and other kinds of components that makes it completely autonomous, right? So, in short, if I put, agents mark the evolution from passive chatbots that we have to active reasoning systems. Okay. Now let me give an example. All of you might be using broadbands at your home, right? So let's say you're having some problem with your everybody's having an app nowadays. Every customer will have an app like Airtel, Geo, Railtel, or Act, anything. And when you, as soon as you do that, all your details have been mapped to this application, and even your device ID, okay, your IP, everything is mapped there, right? So whenever your router is having some problem or your internet is down, right, you go to that particular application and you have a chatbot there, right? So that chatbot, you say that it gives you different options. How can I help you? Correct? That is the first prompt it asks you. Okay. Provide the input that my internet is down. Then next it will prompt you again, or it'll provide the output that what has gone wrong. So it will give you some options there. You select an option there, right? And it will basically ask you to switch on or off the switch off and switch on your router, correct? To restart your router basically. You did that. Still it is not working. Then now automatically, I don't know how many of you experienced this. I have practically experienced this with my Airtel broadband. Next, what will happen is that it will try to connect you to a customer care. So earlier, what happened was that whenever your broadband, like a year back, 1.5 year back, okay, you used to dial the customer care's number and wait in queue for so long, like 15 minutes, 20 minutes. You'll give all the options. Okay, like one, two, three, 8 options you have to give. Then you speak to a agent in the queue. So you used to wait in the queue for a long time, but that's not the case now here. Okay, so all your details been captured, it's trained in the backend, and then what happens that it will directly route you to that particular customer care, and it has already taken all your details such that it routes it to the that particular customer care who can help you with this particular problem. That is what is called as an agent here. Okay, and this at the enterprise level is a big boon for most of the organizations where they're reducing the cost. First thing. Second thing is that they are improving their services by 70-80%, right? 70-80% of their waiting time has been reduced to serve a customer. That's the fact. You can go and Google and you can see some research papers on this as well. It is available in Google. I have experienced this. Right? So that is where these AI agents have come into picture, and it has evolved. Now these agents are again the base of, okay, or it is again a combination of the LLMs, okay, wherein the LLMs has been added extra hands to it. The LLMs has got extra support, I can say, or additions like your memory, tools, and goals. So you say that you basically provide what is a goal here. Based on that goal, it tries to plan, and once it plans, then it tries to act here. So that is called as a GPA. Okay, goal, plan, and act. I don't know how many of you are from the database background or data architecture. Like there are data agents already in the market, like people, so different database industries, right? Or big enterprise organizations, enterprises are developing data agents. Okay, so these data agents will basically generate output to you, visualize your data, and give you the summary insights at the end. How this all happens? So there also the generative AI works into place, but only thing is that the agents have come into place with additional hands like memory, tools, and goals. So based on the GPS score, right? A GPS score will be generated at the end, and that score will basically, if whatever score is the highest, that particular output will be given to the end user. Moving on, we have got agents now. Now, what are multi-agent systems? So multi-agent systems are nothing but at a time when multiple agents are running in a system, right? That is called as multi-agents, or when multiple agents collaborate, right? So in these systems, basically each agent plays a specialized role, right? For example, if I let me give an example of let's say you work in a telecom project, okay, and you want to see that Airtel. I'll just give an example of Airtel. And Airtel company basically wants to see that why the churn rate. Churn rate is something, but the customers leaving the organization or they're not availing the services. Okay, they're dropping the service of Airtel. So every time they want to see the churn rate now. Every time, so this churn rate, predicting the churn rate, right, this can be done in a machine learning way as well, using different classification techniques like whether customer is going to churn or not. If it is churning one, if it is not churning zero. Okay, that can be done in a machine learning. But how do I see such that now the business want cannot wait for months, weeks to see that how many customers are churning. So what they have done is that they have implemented these multi-agent systems where your machine learning model will predict the churn rate, but directly earlier what has happened that there are multiple people working on this thing. Now directly a business executive or the business stakeholder sitting on top can ask the bot or chat bot that give me the list of customers or the number of customers that are going to churn next month. Okay. So when you're asking this, you have given the goal to it, goal to the chatbot. So you will have a planner here. Okay. So planner becomes your master agent here, right? And it will basically share this question to or link this question to multiple agents under it underneath, right? So in this case, what will happen is that when you ask the number of customers, so when you the agent will understand, okay, number of customers, it will go to the database, right? It will go to the database, and there will be a data agent. Based from that agent, it gives the natural language input, and your it is data agent will basically convert the text to SQL. Okay, text to SQL. Please understand this. It will convert the text to SQL and it will generate the output for you. Got it? How many customers? If it is already having the predicted results or the forecasted results, then it will give you that. Or the business executive asks that, give me a list of customers or give me the count of customers they have churned last week, right? So it will basically, when it converts text to SQL, right? The agent will, what it will do is that it will understand, okay, uh, the number of customers churned last week. So last week date range, it will understand which particular data source to connect a database, and under the database, which particular table to connect. And from that table, it will try to retrieve the data and give you the final number, right? And next thing, what is that? If you want to do a little more advanced, if the executive asks, give me the list of customers that are going to churn next week or from the date range. In that case, what will do is that there will be a machine learning model. So the ML planner or the modeler agent here. This modeler agent, what will do is that it will try to grab or retrieve all the historical data. It will try to understand their pattern, okay, of his customer or customer behavior, right? And all their feedbacks or how many transactions they've done, how they're paying their bills or not, okay? And when have they faced any downtime? What were the number of outages? What are the number or how many hours they had this outage? All the data will fetch, it will train the model, it will generate the prediction, and then it will give you the output. Now, before generating this outputs, there will be one more agent called as reviewer agent. So the reviewer agent will basically review all these outputs, whether it is coming from the data agent, whether it is coming from the modeler agent, or whether it is coming from the other agents. Now, these are the different agents. That is why it is called as multi-agent systems. Now, what example I've given is that these are again not the direct thing. There is something called as ops agent, right? So ops agent will basically try to connect or create a loop between all these agents, and it will try to monitor every time the activity of these agents, like how much time it took, what data it has fetched, right? It is very much necessary to have this monitoring tool implemented across all the GenAI projects or any machine learning projects. Otherwise, you will not understand what's going in the backend, because we'll have the data ops agent as well. So data ops agent or the data agent, what will do is that data ops basically, not the data agent. Data ops agent, what will do is that it will try to understand whether there were changes in the data structure, whether there are changes in the data schema, basically, whether the data distribution has changed. So all these details will be there uh, for each agent or that particular ops agent. So that is how enterprises are leveraging multi-agent systems nowadays to completely automate their business processes. In short, if I can put. Okay. So that is what is the benefit of this multi-agent systems that these enterprises are leveraging now. So it is basically uh, scalability, the scalable systems that we have. Then you can create agents with respect to your specialization, whether it could be a healthcare agent or life sciences. Even the hospitals are creating their agents nowadays. Okay. Then you can, in the research field, if you're doing some kind of research like data research and all, you can create that. Then you can do some self-correction agents as well, where you have some documents or some invoices you want to correct them due to some typing issues or the entries you send out. You can use those agents. Okay. So in short, if I could end, multi-agent systems represent the next frontier in AI, where collective intelligence comes into place and multiple models work together to solve complex multi-step problems autonomously.